All right, let's tackle another question. This time it involves a velocity selector and a mass spectrometer. So this question 185, let's read the question. Question 185. Ionized carbon atom with a charge of E are sent through a velocity selector and then go through a mass spectrometer. Calculate the distance d if the mass of carbon 14 and carbon 12 atom are 2.325 multiplied by 10 to the power minus 26 kilogram and 1.993 multiplied by 10 to the power minus 26 kilogram respectively. Just by stating the question, it's not obvious, but we have a velocity selector over here. We have positively charged carbon atom, and they are going through a velocity selector. So basically what that does is it set the velocity at a certain value. Basically it is V will be equal to the electric field divided by the magnetic field. In this case it is 4,000 meters per second. So the velocity will be set, and then it will enter the mass spectrometer and will start a circular path and strike the screen. Now it's not obvious on this diagram, but what they are asking us is since the two atoms has a different mass, they will not strike the screen at the same place. And we want to know what is the difference, the distance between the two places where they struck the screen. Okay, so we need to calculate the distance from the entrance to where, let's say, carbon 14 strike the screen, and then calculate for carbon 12 the same thing and take one of the value minus the other one. This is what we need to do. Okay, so first we know that the velocity selector will have a force of 0 on the particle, which means it will set the particle at a certain speed. So the velocity will be equal to the electric field divided by the magnetic field. Remember, inside the mass spectrometer, we equate the magnetic force to the centripetal force. So the charge multiplied by the velocity multiplied by the magnetic field is equal to the mass velocity squared divided by the radius. Now, in order to, since we have to do the calculation twice, I'm simply going to isolate the radius. Now note, the distance here, the radius from the center of curvature to this point over here, note that this is a distance of 1 radius. The distance from the entrance to where it strikes the screen is 2 radius, okay? It's half a circle away. This will be 1 radius and then another, so it is twice the radius. The distance we're considering, and actually this is di, is equal to twice the radius. Once we isolate the radius here, we got 2. Radius is equal to the mass multiplied by the velocity divided by the charge multiplied by the magnetic field in this case. We replace the velocity with this term and we get that the distance is equal to 2 multiplied by the mass multiplied by the electric field divided by the charge multiplied by the magnetic field square. All right, now we are given in the problem the mass of the carbon 14, the mass of the carbon 12, and we simply need to input all the value into that formula. For the carbon 12, we find that it will strike the screen at a distance of 0.2325 meter from the entrance, from where it's entered the mass spectrometer. And for the carbon 12, it is 0.199. Basically, we want to know the distance between the two spots where the atom strike the screen. We simply take D14 minus D12, and we get a distance of 3.35 centimeter, or simply in meter, 0.0335 meter. All right, so it's not too complicated, but there is some trick that you need to memorize here. You need to understand that the velocity selector will select a very specific velocity, which is equal to the electric field divided by the magnetic field. And again, there's no avoiding the fact that the path will be circular, and we can find the radius of curvature by equating the magnetic force to the centripetal force. All right, we are going to tackle 2 more examples. This time will be on the force applied on a current carrying wire. So let's go to the next video.